thank you all for coming here. I'm gonna talk with you about a specific project that we did in Dow Jones that was actually an idea from a few engineers that came up with this solution. And now let me give you a bit of an introduction about it. So I will first tell you a bit the context. We are in Dow Jones and what is Wall Street Journal Plus. That is where this solution lives. We'll talk a little about similarity and diversity in terms of recommendation and how we approach them quantitatively. Then we'll give you an overview of the first architecture that we got. Then after that, we will go a bit into practice, how some things get together and work. And in the end, a few of the improvements that already were let's say, deployed and delivered on this solution in order to give it a bit more of a structure. So who we are? I mean, Dow Jones, probably you have in mind the index, that the financial index, Dow Jones Industrial Average. I mean, that was produced by the company, but now we are not doing these kinds of things anymore. We are a purely information company, and what we do is that with all the different products that we have to deliver this information, we try to give the customers that we have the opportunity to decide and make decisions quickly, or to have a better experience in consulting this news and getting this information. So on this, our flagship product is the Wall Street Journal on the B2C side. I believe most of you know, but also we have a lot of B2B tools that instead we serve to specific company. An example, Newswires is a way to provide traders information very quickly, or the risk and compliance data set where we give our companies data about the people that they're doing business with, so they know if one of their supplier or someone they are doing business with is, for example, subject to sanctions, subject to lawsuits, or other things like this. But now let's go down to what we talk. So we said that we have a part that is B2C, that is about news, and we have a few journals for this. The Wall Street Journal is the first one, and it has a very broad audience that goes from, I would say, the normal person that wants to be updated on the news about politics and economics and how they influence the markets. Then we have instead another publication. It's called The Barons, that is specifically for investor. I don't expect anyone of us, unless you are millionaires and you have tons of money to invest, to read it to understand on how to strategize over this. But then you will see why I'm telling you what we have. There is Market Watch, that is more focused on real-time updates, and instead it's oriented to a broader consumer audience. And this, for example, you will find ideas on how to invest, for example, in funds and other things that are more accessible to an audience, to a normal audience, or at least to me. I don't have that much money. And instead we have IBD, that is another successful publication that we acquired more recently, that instead focuses on technical analysis. Now, you will say, okay, why this guy is telling us about newspaper? Because the challenge that we, at a certain point, Dow Jones said was we have some premium customers that we serve that are interested into all of this. They have all the subscriptions. How do we try to better their experience, given that they are so premium and they work in this way and are important for us on this level? So our idea was how do we get them a unique experience in consuming this content, and we bring all these four publications together in a single one. And this is the first problem that the people in engineering found, that they had to understand how to do this. And the idea, you could choose between hiring a complete new newsroom to curate the homepage of this journal, or instead trying to do something automatically and, let's say, based on the preference of these people. And that's exactly what it came out to be. It was Wall Street Journal Plus. And you can see now, they are a bit small, but if you look at the titles, there are the different publications that are feeding into this. And initially, our engineering team said, okay, let's take a third-party vendor solution to do recommendations and to personalize content into this. However, this sounded like a quick win, it cost a lot of money. It had many faults in the pipelines. People were complaining. People were saying, oh, it's complex. We don't know exactly how it was done. And also the results, they didn't know too much how to tackle it in order to improve it. So the talk of today is a bit the story on how this engineering team decided to take this at home, trying to do it in their company, trying to do themselves, and get a good result over it. And that's a bit what I'm going to tell you about today. So in order to do this, if we go a bit into the recommendation side, we have two concepts that we have to balance. We have to give similar content to what the user have seen, and instead checking content that is diverse, that is different from what they have seen already. And so we need to have a way to balance these two aspects and to decide how to adapt ourselves in this field. So exactly, that's what I told you. What is, let's say, in addition with this is that this part of diversity is not something new in journalism. It's not that there are papers that you can read about the recommendations that highlight the level, the goodness of diversity in the news. They try to make metrics to measure them, and that's indeed something that can be done. At the same time, when you deal with newsrooms on our side, they have their own idea of what should be dictated in the agenda. And they know that this is important, because if in a newspaper you show all the articles that are on the same topic, you will get only one person to open it, and in specific occasions. So in order to do this, what everyone uses today, I would say, to relate it to how to get text, that is what we have available as a content, and get it in a numerical representation to work with systems of artificial intelligence, are embeddings. There are many types, and I will go into it. So, but just to give you the idea was to balance then a numerical quantity that comes out of these embeddings, and balance how much it is similar based on a measure of the similarity, and balance the diversity always on this measure, but selecting something that is more far apart. So here it's just an overview of what it exists. You can make embeddings and create vectors, so numerical representation out of whatever kind of content that you have. So from text, images, graphs, here we have structured data as well, audio, multimodal things that takes everything together and put them in a single part. What we focus on is on text. On this level, you have either words or documents. In this case, we are talking about articles. So full articles means that we have to act at a broader level. And so we go on the sentence side. And here you have multiple properties, and there is really a zoo of embeddings that you can select from, and you can check a bit what are your, your requirements, and get down to decide the one that fits the most your case. For example, you have a limit of what it can get in the input. You can choose either the language or go multilingual. Obviously, the specific embeddings for certain languages work better. For us, it's English, so it's not even too much to be said, because these publications are all sort of US focused, as Dow Jones is and the Wall Street Journal is. These embeddings can be specified for specifically trained for different tasks and fine-tuned over them. In this case, we are looking for similarity, but you might want to specialize for other tasks in this way. And this is just to tell you, if at a certain point you have a task to do in your own company, you might explore what is the best way for you. There is dimension, how much these embeddings are big. Even here, there is a zoo of things that you can select from. The main idea here is that the smaller the embedding is, the less your database should be large. So it's mainly, usually more higher dimension can be more accurate in certain tasks, but at the same time you might want to optimize over it. And in the end you have fine-tuning in the case you have specific tasks or in general specific domains where you want to tailor your embedding for. And in this kind of situation, for example, I don't know, medical reports, financial, very deep financial analysis, you might want to act in this way and try to teach your embedding to recognize certain nuances. So here, I start with what we use. At the moment, we use Gecko. That is very helpful for managing the size on the database and to optimize. And it's still a decent embedding. We use the English version for this. And we have good performance, I would say, nothing to complain on this side. You can get something more like recently, again, staying with Google and Gemini, they released a way more performant model that is multilingual, way larger, and you can use it for different tasks. But just not to leave you with the impression that you just have to stick with Google, you can go also with Qwen, with Alibaba, and all these, these embeddings, for example, perform well. They are open source. You can use them. You can try them. So that's a bit what you can get. In here, as I mentioned to you, it's always, everyone a bit in the field knows that you can have public data sets that you can, where you can score your model, but in the end, until you go into your domain and you try things out, you can never be sure of what is the outcome and if it is exactly what you want. However, it's still a good place where to start, and there are leaderboards that can tell you how the embeddings are done. Here you can see about for the tasks and the number of parameters that you have. This is the Hugging Face leaderboard. You can check specifically for each task how they are performing, and yes, and that's a bit it. Now, on what happens in practice. So after you select the embeddings that are good for you, and you try and you try to test them out on a small sample, what you have to do is a bit to work with them in practice, because embeddings, as you saw before, they have a token limit. So you cannot give to these embeddings too much text over it, especially if these are long articles, and sometimes opinion articles can be very long, or especially if the analyses are particularly deep. And so what you have to do is just, based on the embedding size that the token limit that you can get, you should chunk your text, divide it, keep some zones that are in overlap, and generate chunks on from these chunks, the embeddings that you have, store them, have an idea of the structure of what belongs to the same document, and what instead needs to be, grouped outside as a completely different one. Here, what you do in order, so to go back to the two concepts that we mentioned before, you go with similarity. So it's a distance similarity, what we call cosine similarity, is the difference between the angles of these vectors in the embedding space, obviously with the number of dimensions that these embeddings have. And what does it mean? That if two embeddings are more aligned together, usually they have a more similar meaning, and that's what the task on which they were trained for. And instead, if they are more orthogonal, more far apart, these two embeddings have way less related meanings. In this case, just to make you an example, very stupid, but gives you an idea, if you have two sentences like this, one about trekking in Montserrat and one about the Sierra de Tramontana, both mountains, both about nature, but not exactly the same thing, you will get a more similar result with respect to something that is completely different. For example, if I put inside the abstract of this talk, I will get something that doesn't connect at all. Yeah, there is a simple way to test it online with whatever you get. I don't even need to write a part of the code to do it. And you can see that the similarity between the first two sentences is 0.4, nothing gigantic. So it understands that the two embeddings are talking about something similar, close by, but very different, but different. And instead, on the second case, you see the comparison with my abstract is completely off, up to 0.5. And this with something that is publicly available, nothing particular. So how do we come here? Let me get a bit of water just to continue. So now that you have an idea of how the mechanism works, personalization plays a bit with these two processes. The first one, we get the reading history of our customer that are usually a list of articles that we can decide how many. And the first approach that we took was to take the initial part of the article, because there was this idea that in the beginning of the article you get the most of the content and you get to know what the article is talking about. Then after this we compare with the cosine similarity through all the other embeddings that there are in our database, and we select the ones that are surpass a certain similarity threshold. In this case, we could limit also to not to get to similar results, but this you will see later instead how we decided to tackle this. Obviously, then on the next slide I will tell you a bit where these things happen. Instead, for the diversity side, what we usually do, actually what we do, is that we apply a hierarchical clustering. Many people, I believe here, that dealt with embeddings and NLP, in NLP tasks, for example, topic modeling, might raise their eyebrows when I mention hierarchical clustering, because if looked on the topic modeling side, it doesn't usually deliver the best performance, at least in 2 or 3 cases that I dealt with. But in our case, it has a property that is very interesting, that is the fact that you can always change in very simply after you get the solution, the level at which the cluster is and how many clusters you're looking at. And always try to find something that belongs to the same group as either below or above with respect to where you are. And this is done, obviously, there are different ways to set up your hierarchical clustering. It's not one click and go, but usually, and it has its own internal metrics to verify if the solution that you get is more or less good with respect to the standards that it expects. But after you set it up, you get your result, you get the hierarchy outside, and you can use it to work on your content. So, how do we put these things together? So here is a bit the architecture in general. I will go step by step. First, we have Parsley, a third-party vendor about the activity that we get on our web pages over the articles. There is a stream that takes this data in, obviously with all the filters of the case, dividing between environments and everything. We trigger a Lambda function that saves the additional new views that our users do in our database where we store these what we call user profiles. At the moment, the user profile is only about articles that are read. Then, when the user profiles are updated, we kick off another project with a Lambda and a QE system. We need a QE system because then we start the embedding generation. And obviously, we cannot call how many times we want the Google API that we trigger with a Lambda. So here the process is the following. We get from our shared data layer that we have the content of the article, headline, the first part of the snippet if we want. Later you will see we can also get the whole content. Get it back, generate the embeddings, and then store them into an embedding store. Here, what we have now is that it's what happens when the user instead visit Wall Street Journal Plus. So it arrives, the front end calls to a personalized subgraph in our shared data layer, and this gets the embeddings from the store that we have here. At this point, what happens is that on one side, we have a search team that has a vector database. In this case, here you always saw Dynamo because we didn't need to to search by the embedding itself. It was more on the user level as a key. Instead, here, when we go with vector search, we can give our embedding and search for a matching embedding in this way. So after we do this over this database, we come back, we have our embeddings, and we perform the clustering that I told you. In this way, we fetch, we reduce the amount of elements that are available, and the clustering is quite quick and gives us that solution. Now, how things get together on the homepage of Wall Street Journal Plus. So okay, the order is, so in Wall Street Journal Plus, just to give you an idea of how this architecture puts these things together, we get between 10 and 50K users, so it's not gigantic as Wall Street Journal, and it fetches 3 days of articles in the recommendations that it got. Between, you can think about 500 and 2,500 articles per day. And now, I told you how does the clustering appears. The clustering is used to fill the different sections of the home page. So if this is the Wall Street Journal Plus page, obviously scrolling a bit down and zooming to show all the sections. If you look up here, there are these zones that are belonging to different clusters. And you can see that in 2 zones, we have some sub-articles that belong to the elements in the cluster below, and some others that instead have less content. In this way, it's where the hierarchical clustering comes handy. Obviously, first we fetch, so we reduce the number, and then we separate these, and we can decide based on how different they are, to which cluster they belong under the first, in the following level, we can diversify what we give here. Moreover, this gives flexibility because we have a newsroom that obviously has its own idea about how to present things, how the homepage should look like. And having an idea of clustering makes you very flexible because if, let's say, one day they decide, okay, let's not have this big section at the beginning, but let's have 9 clusters over it, as it was, I would say, 2 months ago, it's very easy for us to adapt to their request and change what we provide. Then, when this was delivered actually as a solution in production, and we changed with respect to the third-party pipeline that we had an uplift in the click-through rate of 22%. As I mentioned, not in the best way possible because it was seen as a before and after, so not as an A/B test. It was sort of an internal experiment that went well and people got excited. But this was a signal that convinced them to roll it out. And over on top of this, however, I'm quite sure you might see that there are some improvements to be done, and in fact, that's what we did on top of this. So the first part is that now you see that we collected all the embeddings and we generated them based on the user history, thinking that we needed the embeddings to have, let's say, all the context of text together in order to generate a meaningful embedding. In reality, that is not too much the case. We experimented with a linear combination of the vectors that simplifies a lot the job. Instead of having a new user reading something new and having to recompute the embedding and spend money over it, what you can do is to get the articles that you get, create their own embeddings, and then assemble them. Here, the pipeline changed in a slight way, so we always have the user profiles get informed, especially with all the articles that are updated. But this time, instead, we have a system that we get the notification when a new article is out. We queue for embedding generation, then we store this in the embedding store, and then once we have the embeddings for this article, we cache them in order to have a quick retrieval. Why a quick retrieval? I mean, I mentioned it already. Now, these embeddings should be retrieved by the personalized graph together with the user profile. So first we get the user profile, we get the articles, we get the embeddings from cache. We compute now the user embeddings with linear combinations, and we can experiment on if we want to give decays based on if it is the last read or the first read. And then we do the 2 things as before. We go with with the vector search, and then with clustering on this database. So after this one, now we introduced A/B testing because product people were quite strict over this, and I believe also it's the way to go. And actually, when we introduced this system with the change, we were able to exclude up to 2% that there was any change in the CTR over 1 month that we had the test running. So this was a good enough result, people said, okay, no change in performance, but instead we save money on the embedding generations, let's go in this way. In the future, it might be interesting to add something like MRR, for example, to check whether the user clicks on what we believe it's their first choice on what they want to check. Another thing that came out as interesting is that we had to detect contradicting information because, embeddings looks whether texts are similar. They don't check whether the articles present different information at different, on the same topic. And this came in this way. So, for example, you have one day the Dow Jones jump, the other day the Dow Jones fall. If we provide all this view together to our users, they might say, okay, why they are giving me this information that comes from different data doesn't make any sense. Show me just the last one. And given that we have tons of market daily updates, that's what actually happens. Here is Spotify. On one day, Spotify plunge. One day, Spotify rebound. And it also can be a problem with the current market data without having any update. So what happens is that, for example, here we had an article about Trump tariffs that crashed the stock market, and instead the stock market was very green and was growing that day. So there was a bit of an issue over here. What we tried to solve it adding a zero-shot classifier over here. So you can see here this is a very simple prompt with very few iterations to get it. Takes the headline, the snippet that is the first part of the article that I mentioned to you before. So we are using it again in another way. And we have a constrained output to tell, is this an article about the financial market that has a daily granularity? It has a more deep granularity and therefore let's say it has a daily relevance, I would say a more deep relevance that can be used on the next months. For example, an analysis of the barons on certain stocks could be helpful to be read even after 3 months. It's not that the company situation changed that much. And instead, or for example, if it is not related to market. Here, this classifier was quite able to identify what was daily content. We had, from our sample, over 100 articles per publication. We manually labeled. It's not a gigantic effort, as you can see. 100 articles is quite, if you are fast, you can do it in 1 day. We get a very good result because the error rate was 2.5%, precision and recall balanced. We could also estimate how much this error rate could change if, based on the selection, if we would have increased the sample size. And also here we tested a bit with the Flace kappa to check how much the article, how much our model was reliable and the evaluations didn't change over time. Given that the results were that good, we could expect a Flace kappa to be very high, but still it's good to check and to see the behavior of your model, how it works. This is a case, so after we get this classification, now that is not super interesting, but on our side, we have some codes within the company identifying when certain companies are inside of a certain article. We know how to check the relevance of this, and we combine this with our flag, and in this way we are able to remove articles that are sort of outdated or that comes from the previous day. And if we find that the codes are not reliable, we can simply say, okay, apply a stronger decay on your content relevance, and this article will die faster than the evergreen ones. This is a bit, we talk about evergreens because this is something at the moment you saw that we fetch 3 days of data. We have a way richer, I would say, collection of articles that can be reproposed and that users might want to read. And at a certain point you get interest about something, and there was an analysis created 6 months ago about the same topic in a very deep detail. And this approach that you saw just now, the idea is also to reapply to identify these golden articles that we might want to suggest and to put back in. In the end, who is a bit familiar with recommendation might know that we did the content-based recommendation at the moment. We have not touched anything about collaborative filtering or other things. And this is a bit what is going to start. We have a nice project for the next quarter. What we did before was done last year. So it was a quite good change and empowered a bit also our team to be able to play with this and to deliver good results in a cheaper way. So here I open a bit the stage for you for questions if you have them. I've been a bit fast, so but let me know if you have something that you would like to know more.
Any questions then?
Thank you. Thank you very much for the talk. So a bit a question about the next steps. So given that you have a lot of textual information that you reach, if you move into collaborative filtering, are you thinking more about a hybrid approach or pure collaborative filtering? So,
no, indeed hybrid, because we have this, we are quite happy over this. We saw that it played a big role. It will actually be a question to explore whether adding collaborative filtering improve the pipeline and the results in a specific way. So that's
I think, and do you have a specific framework if you're thinking about like maybe TensorFlow recommenders or anything that you already explored, or is it a kind of thing it's to be decided yet? And
no, it has to be explored. We have to start on the. I mean, there are some ideas on the table, but we have not put the things together and tested out what are the early results to check how much we can push or how much something delivers additional result.
Yeah, thank you.
You're welcome.
Thanks for the interesting talk. Very, well, maybe primitive question. Did you play around maybe with the chunking and the embeddings, and how would they affect the quality, the end quality of the results? Or was it very sensitive to those? Or
No, actually it was not. I have to say that we are also quite lucky over that, because how to say, Gecko has a limit of token that is quite high to start with. And as I mentioned before, something that also the newsroom told us, but also we explored it out, is that articles, the main content of the articles stays at the beginning. So sometimes it's good to check on the other side if we match with different parts of the content that we have. But usually on the story side, we started with just the snippet, and it was easy. And in this way, we also avoided the chunking at the beginning. But later we try to introduce it more and to have how to say, in the average of the embeddings that we are considering having this additional element, and it's not that it changed dramatically what we saw. So.
We're still on time. Any more questions?
Thanks for the talk. So did you maybe try, because now we have LLMs, did you try summarization, like instead of chunking, having LLM produce a summary of the article? Is it worth trying, or are there any?
On my side, I mean, it's interesting as an approach to get the embeddings, I mean, to get something that is, I would say, unique. However, it adds token cost on what we do. And that's mainly, at the moment for how embeddings works, they work very well. And also something that, also a bit the signal that I would like to say, it's very feasible to build something in-house, even if for a product like Wall Street Journal Plus that has a lot of very exigent users. But adding summary, so at the moment we didn't see a problem, and it seems to work well. It could be done, but it comes with the additional token cost of summarizing the articles.
More questions? No? Okay, I think that's it.
Thank you. Let you go for lunch.
Thank you.
Have a good day.